Welcome back to Math Concepts. We are going to continue working with compound interest here, and we'll look at some examples of using the compound interest formula to find what is sometimes called the compounded amount. In other words, you make a deposit into an account earning compound interest. How much do you end up with? That's called the compound amount. It's also sometimes called the future value. So we're going to do some examples with that. I do recommend you have a dedicated calculator for this. You will need something that is capable of doing exponents. Okay, so when we're done with this video, I would expect you to be able to use the compound interest formula to compute the compound amount / future value. So we'll go over a couple of examples. This first one says, calculate the compound amount when $4,000 is deposited into an account earning 6% interest compounded monthly for 2 years. All right, so if you go back to our last video, we know that the compounded amount is equal to the principal times 1 plus r over n exponent nt. All right, let's fill in everything that we know. Principal, that's the amount you initially deposit, $4,000. That 1, that's always there. Okay, remember, you keep 100% of what you had plus this additional little bit. Okay, now what's that additional little bit? Well, in our case, it's 0.06 divided by 12. Okay, now why is there a 12? Well, the interest in this example is compounded monthly, and there's 12 months in a year. Okay, so that's the number of compoundings per year. Now let's look at this exponent. Okay, n, which we know in this example is 12, and then t is time in years. Okay, so that's going to be 24. Okay, the way I think of this is the exponent should be the number of interest periods you have gone through in total. Now, in this example, your interest period is 1 month long, okay? Every month you get interest. You're doing that for 2 years, so you're going to get interest 24 times. That's what your exponent needs to be. All right, now, when you're using your calculator to do this, you can pretty much just type it in like exactly as it looks right there. Let me get out of that light. There's a little bit of glare. Okay, so this is what we're going to compute. We'll do it on our calculator. Okay, so clear. And we're going to do 4,000 times, do a parenthesis, 1 plus r, which is 0.06, that's the rate, divided by 12, close the parenthesis, exponent 24 equals. Okay, so very easy. 4508.64. Okay, notice that I rounded to 2 decimal places. Okay, we're dealing with money, and the smallest amount of money that we can have is a penny. So we don't want to carry anything past that second decimal place. Notice also, I didn't do any rounding at the beginning. I rounded at the very end. Okay, make sure that when you're doing these compound interest problems, you wait until the end to do any rounding. Okay, let's go down to this next example. Calculate the future value. Okay, notice there's a slight difference in the way they said things. Compound amount and future value. That's just 2 ways to talk about the same thing. Either way, we're wanting to know what do we end up with in this account. Okay, so the amount we end up with is the principal, $2,500, 1 plus, I'm just going to jump right in here. We've got the formula right there. In this case, the rate is 9%, 0.09. It is compounded daily. Okay, now I'm going to follow the convention that our textbook uses, and whenever they have daily compounding, they use 360. Just something they do. All right, now we're doing this for 4 years, so I want to know what my exponent should be. Okay, so 360 times 4, 1440. Okay. So, we just have our calculator do the arithmetic for us here. 2500 times, open a parenthesis, 1 plus 0.09 divide by 360, close that parenthesis, exponent 440. $2,790.66. Okay, remember once again, when we're doing these compound interest problems, we do not round until the last step. Okay, you can get into big trouble and get your answer way off if you round too early. So don't round until the very end. And of course, we always round to 2 decimal places. All right, so this is the formula that we use right here for dealing with future value problems. It's also called finding the compound amount. It's when you know what you have at the beginning and you want to find out what you're going to have down the road.